Okay, now we're going to find the area of this, well, the perimeter, the apothem, the area, all that stuff of this equilateral triangle that is inscribed inside this circle. Okay, so first of all, we know that the side of the triangle is 4, so we know that the perimeter is just 3 times 4, which is 12 units. All right. The central angle is going to be 360 divided by 3, since there are 3 sides. So 360 over 3 is 120. So this angle is 120 degrees. All right. And since that is 120 degrees, and this is an isosceles triangle here, we know that these angles are going to be 180 minus 120, because this triangle has 180 degrees total. So 120 minus 180 is 60. So each one of these is going to be 30. All right. So this little triangle here, this little triangle is a 30, 60, 90 triangle. So again, in this problem, we're not going to need to use the trig functions because we already know how these ratios work. All right, so when you drop the apothem down to the base, you break the base up into 2 equal parts. So each one of those pieces is 2. So this is the long leg of this 30, 60, 90 triangle here. So the long leg is 2, which means that the short leg is going to be 2 divided by the square root of 3. So the apothem is 2 divided by the square root of 3, and then if you rationalize that, that is 2 times the square root of 3 over 3. All right, so now we need to find out the radius, which is the hypotenuse. So the hypotenuse in a 30, 60, 90 triangle is twice the short leg. So the radius is equal to 2 times 2 square root of 3 over 3, which is 4 square root of 3 over 3. So that's the radius. Now we're going to find the area. The area of the big triangle is equal to the area of this triangle times 3, because there are 3 of these in it. So area is going to be base times height over 2 of this triangle times 3. So the base of this triangle is 4. The height is the apothem, which is 2 square root of 3 over 3. And we're going to divide that by 2 and multiply the whole thing by 3. All right, so let's see, this 2 cancels. And so we have 4 square root of 3 over 3 times 3. And that's going to cancel, so we just have 4 times the square root of 3 square units for the area. Okay, now again, with this triangle, with a triangle and a square, I mean, we already knew how to find the areas of those things without doing all that. So really, the next one is the first one we're going to do that we really actually have to do it this way because we don't know how to find the area of a hexagon the way we do with a square and a triangle. All right, so this one will be a little bit more, this is why we're learning this. Okay, so we've got a hexagon, 6 sides, with a side of 4. All right, so the perimeter, that's easy enough. 4 times 6, so 24 units. The central angle, which is this, is going to be 360 divided by 6. 360 over the number of sides, so 60 degrees. So this is 60 degrees, and since this is a isosceles triangle, that's 60, so 180 minus 60 is going to be 120. So if I split 120 up between these two base angles, each one gets 60. So again, we're dealing with 30, 60, 90 triangle in this problem. All right, so the central angle is 60. The apothem is what we need to find next. We know that if we drop the apothem down, it breaks the base up into two pieces, two equal parts, 2 and 2. All right, so, and now we have a 30, 60, 90 triangle, and we know the short leg, which is 2. The long leg is going to be 2 times the square root of 3. So the apothem is going to be 2 times the square root of 3. All right, the radius is the hypotenuse of this little right triangle here. So that's double the short leg, so 4. The radius is going to be 4 units. All right, so we've got everything we need to find the area. Base times height over 2 times 6. All right, so base area equals base times height, which is the apothem, 2 square root of 3, over 2, and then all that times 6 triangles. So 2 and 6 cancel, so you got about 3 there. So 24 square root of 3 square units.